Okay, so now we're going to take a look at these that have variables. So first off, we're going to simplify this one, and we can do that by simplifying the square root of 50. Well, we can go through the list. When we go through the list, we find the correct factorization to be the square root of 25 times the square root of 2. We're going to go through the list with the square root of x to the fifth, though. That could be a bunch of things, right? That could be the square root of x times the square root of x to the fourth, or the square root of x squared times the square root of x to the third. Well, I guess not a bunch. I guess that's it. And the only one of those that I can actually have, or I can have actually square roots in both cases. I can look at the first one there, and I see that there's a square root there, and there's also a square root there. I take the bigger of the two. So I'm taking the one, the square root of x to the fourth, square root of x to the fourth, and then the square root of x. Doing the same thing over here, well, let's see, x squared. The 18, I can break that up and I can go through all the factorizations, but the 18 has a 9 in it. So I can break it up that way, I know. And the x kind of just has to stay, because whenever the index is larger than the power, if the index is larger than the power, then you don't have to simplify any further. Okay, so let's see. This one leads me to a 5 square root of 2. This, the square root of x to the fourth, is actually x squared. Let me put that over here. So that's actually x squared. And then this, I'll just stick that underneath that same radical. Just stick that underneath that same radical. So that's the origin of everything there. That's where everything is coming from. Then there's plus here. Then this is x squared. This, oh, that's the square root of 9 is 3. So 3. That's where 3 is coming from. That's where the x squared comes from. Oh, and those same two things will stay underneath a radical. Both of those, 2x. Oh, that's nice because that's the same radicand in the green one. So I can actually combine these then because they're like radicals. They have the same radicand and they have the same index. And also, actually, they're like terms because the variables are identical in both cases. So we have 5x squared of that radical plus 3x squared of that radical, which makes 8x squared of that exact same radical. Answer. Let's try one more. Add or subtract as indicated. Okay, well, once again, we're breaking this one up. These are cube roots, so these are slightly different. They're not square roots anymore, they're cube roots. So we have 2, and then we are going to break up that cube root of 250 into two parts. The two factors I know I'm looking for because I know that 125 is a perfect cube. Um, the other factor would be 2 because 125 times 2 is 250. There's many factorizations of x to the fifth. Well, I say many again. Like we can take the cube root of x times the cube root of x to the fourth, but that's not helpful. We can do the cube root of x squared times the cube root of x to the third. That one is helpful. And that's the last one. So this is the one we want because we need that. Because we need that. We need that because the cube root of x to the third is actually pretty straightforward. And of course we have the cube root of x squared as a straggler. Then we'll do the red one now. So minus, and then it's 3x, 3x. Oh, and just like before, that 2 is smaller than that 3, so that doesn't have to be simplified any further. And the 2 is also a prime number, so it has no factors that are perfect cubes. Alright, that's awesome. So I don't even have to simplify this second one, 2x squared. Alright, let's see what we got going here. So this 2 here, the cube root of 125 is 5. And then this, the cube root of x to the third is x. And then this one here and this one here, these two, they're going to stay underneath the radical, the 2 and the x squared. So this is where this comes from, and the other 2 comes from here. Alright, we still have minus 3x cube roots of 2x squared. And now, product, rational ones, that's 10x cube roots of 2x squared, and that's going to be minus 3x cube roots of 2x squared. And those are like radicals. They have the same radicand and they have the same index. So therefore I can subtract them. And they're also like terms on top of it, because 10x minus 3x makes 7x cube roots of 2x squared. And that would be the final result.